And so to start with, I just wanted to briefly talk about how important continuous integration and delivery is. And let's go ahead and start there. So if I go through and talk about a cloud-based development environment first, development environment. This is really the I think what's happening now is that most people are really focused on building in some kind of environment that's reproducible. So that's really the idea here, is that when you have a cloud-based development environment, that the exact environment they're developing in is able to be replicated into production. So if we make another copy of this thing here, and we make another one here, we can see that the development environment is essentially the exact same as the production environment. And what that does is it gives us the benefit of being able to use a build system for testing and for deployment. So if I build out a build system here in the middle, maybe we'll make that a slightly different color here, that this build system is going to be really the automation factory. So we can think of a build system as the automation factory, and this is really where everything occurs. So if you want to find a place that has problems with operationalizing things, they're going to have real problems with this, right? They're going to have the build system won't be able to do continuous integration. The build system, won't be able to automatically deploy. This is where, if I was looking at a problem in some kind of organization, it's going to most likely, if it involves DevOps, it's going to there's going to be something wrong. Either there's no build system or the build system needs to be fixed. So what are some of the things that you can do with a build system? Let's just enumerate those. So, I think the first thing that we would care about with a build system would be to do testing, right? And so one way to put that is, CI, right? Continuous integration. The second thing that we would care about with a build system is that we are going to care about also deployment. So if we go through and we check out deployment, that's going to be a key task. So that could be the CD aspect of it. And then if we wanted to make this also about containers, right? You most likely would be doing something with containers in your environments. And we can make this a little bit bigger, so we can say containers as well. And that's going to be basically pushing things to a registry. And then the other aspect of a build system is that it's basically a replica of your environment as well. So in this particular scenario here, this build system is going to be a complete replica of exactly this development environment and this production environment. And we can put a note there. We'll call this prod, and then we'll make another note here that calls this dev here. So in the build, if we go through here, we make a build environment. So we'll say build environment, dev environment here, and then prod environment. There we go, prod environment. Here we go. And what's fascinating about this particular scenario is that really it's a form of automation. Anytime you're doing DevOps, the goal of DevOps is effectively to get better and better automation that improves the quality of the system that you're trying to build. And so in the middle of this, this is really the step here. I guess I could do go to a different pin here real quick. Let's go to a pin. And so in the middle right here is where we would have the automation occur, right? So we would essentially the way to get from dev to production is by this build system. If you don't have the build system, you would have to manually do it, and that's really the goal of DevOps is this step of automation. So in order to do that, what we're going to do to start with is I'm going to go over to GitHub and I'm going to use a feature called Codespaces. Let's go ahead and take a look at this real quick. One of the nice things about Codespaces is that Codespaces is now free. So if you wanted to replicate exactly what I'm doing, you could do the exact same thing that I'm doing. It's free to everybody to use now, which is really awesome. One thing that you do have to do is actually clean up sometimes your Codespaces, because I use them so often. And if you're not using one for a while, for example, you could just delete a couple of them, and then you'll have more room. So I'm going to delete a couple and then get into it. So when I use Codespaces, typically the way I use them is I use them from a template. And so if we go over to here, one of the templates that I've created recently is called a Python template. Let's see, Python template. And so this Python template here, it basically has a makefile in it. It has a testing integration. It has a little bit of libraries as well. It has Pylint installed. It has Docker. It has Copilot integration, and it has Jupyter Notebook, IPython. And so this is essentially, for most Python projects that I'm working on, this is a pretty good template to use. And so what I can do here is actually use this template in order to build another template, right? Or I could use it to just build out a series of instructional videos. So I'm going to go ahead and I'm going to use this template, and I'm going to create a new repository based on this. And I'm going to go ahead and put it into here, and we'll call this DevOps, and we'll say 2023, and we'll put a description here that says this is a GitHub Codespaces DevOps tutorial over several hours, right? And I'll do public, and I can go ahead and say create a repository from this template. So this template concept is pretty awesome because you can really have a core. Like in my case, I have all the goodies that I typically use, and then I can build off of that. Additionally, one of the really cool things that you can do is that we can use this Codespaces concept. And so Codespaces allows me to launch in the cloud. And so one of the things I'm going to do real quick here, since I'm going to be using this environment quite a bit, is I'm going to scroll down and look at these settings here in general. And there's a few things that are important to do DevOps. In particular, one of the things to be aware of is that for code and automation here, that you're probably going to be changing some of these features. And then for security, you're also probably going to be changing some of these features as well. So for example, if you wanted to do a deployment and you wanted to use GitHub Actions, this would be something that you would need to go into and add some keys. If you wanted to do integration to, let's say, AWS Cloud and use your API keys, this would be a good one. All of these are great resources to play around with. In terms of the Codespaces, one of the things that we can do, in this case, we say Prebuild configuration, as you would say setup Prebuild, and then for here, we can say main. There we go. And then in terms of configuration file, notice that there's a dev container configuration file. What a dev container configuration file does is just customizes my editor's environment. And so I'm going to go ahead and tell this thing, hey, I want to automatically build the environment for myself every single time there's a change. And so that means that when I launch it, it'll be a very fast launch process. And if we go ahead and we go back to the repo here now, and I go to code, this is where I can launch my own code space. So again, in the future, it'll be a very quick process, but it'll take a little bit of time to load it because we haven't done pre-builds yet. So I'm going to go ahead and say new with options right here. And then depending on what kind of account you have, I think if you have a free tier account, you'll just get this, which is fine. Or if you have a paid account, you can get super powerful machines. For example, you could get a 16-core box with 32 gigs of RAM, or a 6-core box with a GPU. In this case, I'm going to pick the 16-core box and then go ahead and say create Codespaces. So this is why the pre-build process is kind of a nice process to set up, is that you won't have to go through and like it takes a few minutes to build this. You don't have to do this if you have set up pre-builds. Now, the first time you're setting it up, though, it's not bad to just take a look at it. So we can go here and we can look at the logs. And especially if you're a DevOps person, I think it's important to get in the habit of looking at logs, looking at output. There's a lot to learn by watching this. And so you can see in this particular scenario, we're installing packages, we're building different things, and we can identify each of the steps that are important while this thing is built. And in this particular scenario, it looks like now it's installing some Ubuntu packages. So first it looks like it did some Python. Second, it's doing some Ubuntu. Now it's doing some CUDA stuff as well, so that GPUs could be available if you needed them. And then again, there's a lot to learn by just watching the output of something, so that in the future, if you needed to debug something, you have some idea of like, oh, okay, I need to do this change, or I need to do this change. But the idea here is that you're able to go through and see each of the steps. Now, the nice thing about setting up things yourself with Codespaces is that you actually have a container in order to work with. So I can always change the Docker container anytime I want, and go ahead and tweak it, or add packages, or go into the dev container config and add more extensions. All of this is customizable, and I'll show this real quick. If we go back here, where would you change all these things? Fortunately, it's completely transparent. If I go to DevOps here and we go to Docker file, I can go inside the Docker file, and I can add anything I want, right? And so this is what's really powerful about the Docker file, is that I can say, apt-get update, apt-get install, no install recommends, and go ahead and put this in there. I also can do the requirements file copied inside of there. I can also copy the make file inside of there. All of this stuff is customizable. I can literally change anything I want, including even the base image that I'm pulling from. So it's really kind of a new way of working, in that you have explicit control over every single aspect of what it is that you're developing in, which in turn could be exactly the environment that you deploy into production, and the exact environment that you're actually doing testing on. So this is really an amazing tool, in my opinion, and the future of these kinds of tools, these kind of cloud-based development environments. So if we scroll back here, you can see that it's finished, right? And now it's doing the final steps, and we should be able to use our environment. So a few things to point out here, as I mentioned before, now Codespaces is free, so it's kind of no reason to not use Codespaces, even if you're using other environments, your local desktop, etc. It's just a nice complementary tool that it is really powerful, and I'll show you why some of these things are powerful. So to start with, one of the things that I'm going to cover is that notice that I've set up a virtual environment automatically right here. And the reason this is kind of nice is that now I don't have to worry about weird things happening in my Python environment because they're all going to be installed inside of this code space. Part of that is that in the setup tool right here, if you look at the setup.sh, what I did was I added this step, which is source, home, Codespaces, virtual environment, bin, activate. So essentially I sourced the virtual environment, and then I also echoed that into my bash RC. So if we look at the bash RC file here, so if I say vim tilde.bash RC, look at this. We see at the very bottom that the Codespaces is always going to activate my virtual environment for me. So it's essentially, completely set up in the way that's going to be helpful for me to build software. Now, the other thing that's really cool about this is that I use a makefile to really orchestrate all the different steps in my project. And this is really critical. It seems simple, or maybe like, hey, why are we doing a makefile? But the reason why you use a makefile is it makes things less complicated when you later do continuous integration or you later do continuous delivery. And that's really the advantage of a makefile. Let's take a look at these steps here on all the different things inside. So first, we have the ability to install our packages, right? So if we go to requirements, we see here's some of the requirements, and they're pinned as well. So I know that they're gonna load the way that I expect them to load. And then if we go back to the makefile, we also have testing. So in this case, I have a small little library here. That's kind of a toy library. That's a calculator function. And we actually have a test for it right here. So we actually go through here, we do a small test. So again, this is just getting the scaffolding ready. And then if we go to formatting, right, we can actually go through and we can format all of our code using the Python black utility. And then linting is critical for Python. I would say even if you, for some reason, don't have time to do a test on a really quick project, it's essentially never a good reason to not lint your code either using the PyLint tool or the Flake 8 tool or some other linter tool. It's critical to do this because Python is not a compiled language. It's interpreted. It's always going to have bugs, in there, and you need to flush out those bugs. And that's what the linting does. Now, the other thing we can do is, and we'll get into this in a little bit later, but we have a Docker file with a really simple config here so that we can test out containers. And in fact, I can do a lint process for Python, and I can do a lint process for containers because I can use this Docker run command to run the Docker file lint here. And then if we go to refactor, we can do format and lint, right? So this is what's nice about having a makefile is the exact steps I do here. I can do those exact steps inside of my continuous integration environment. So let's go ahead and try some of these. So let's go ahead and do make install. Let's double check that right here. And we see make install. It's going to say, here we go. Look, all the requirements are already met, so we don't have to do anything other than maybe pip needed to be there. There's always updates to pip. The other thing that we can try is we can try testing, right? So let's go ahead and try that. We'll say make test. Here we go. All the testing passed, right? And we can also do make lint here, and the code is able to lint. And I actually do testing and linting so often that I've actually combined them together into something called make refactor. And what I do here is I just type in make refactor, and I find myself doing this really periodically, just as almost like a compilation step. If I was using a compiled language, obviously I would try to compile, the code constantly. In this case, I'm essentially using linting tool and formatting tool to clean up the process of what it is that I'm building. And then finally, down here, if I wanted to do all of those steps together, here we could just say make all, right? And so if you were going to hand this project over to somebody else on your team, or you were going to, check it out in a new environment, it's all one step. You just say make all, right? So I have found over years and years of decades of programming in Python, this style is a very good style. And when I teach this to new students, they use this style, and I found it's like a hot knife through butter. It cuts through a lot of problems that people have. So I would definitely recommend it. Now let's go even further now and see how this corresponds to DevOps. If we look at GitHub Actions here, which is our continuous integration environment, look what I did. There's almost nothing different that I needed to do inside of this GitHub Actions file because of the fact that I have a make file. all I need to do is set up steps. So in this case, I say run, make, install, and it does the exact steps that I did locally. When I want a lint, I just say make lint. When I do a test, I want to say make test. If I do a format, I say make format. If I do a deploy, let's do make deploy, right? And what's critical about this is that you're able to really completely reproduce the steps that are necessary inside of your build system only by running the steps that you have in your makefile. And I think this is critical because it makes it less likely that you'll have cut and paste errors or a different configuration in your build system that you have locally. It's really easy. Like if you took a command like this, what if you accidentally put it slightly different into the build system and then it doesn't catch a bug, right? And then your deployment process has got a hole in it. That's why it's important to do the same thing in your local environment that you do in your production environment. And it's very subtle that it's like, oh, well, why would I really need to do this? Because it happens. And I've seen it happen in many different companies I've worked at where someone has a different setup in their build system than they do locally. And then there's a problem that is able to be leaked through. So it's the reproducibility, I think, that is really the key factor here. So now that we've got this great environment here, let's go ahead and just test out a couple of the things that it can catch from testing. So one of them is we have this really small application here that in this case goes and says, let's add our code together, right? So we can just test it out real quick. Now, one thing I'll point out is Chameleon Tools. I like to do this. I like to do, so user bin env Python. So I create a shebang line at the top, and then I also do this as I make it executable, so that now I can just do this, and we can do -- help. Here we go. So he says show this message and help, and we can even tweak this Chameleon tool to make it a little bit cleaner by adding some documentation inside. And because I have Copilot inside of here, which I'll show in a second, it can do some really cool stuff. Like it can do this, and then we can say example, right? So it can basically write my documentation for me, which is pretty cool. Although in this case, I think I'm gonna tweak their documentation so that it works like that. So now if I do help, there we go. We have kind of a nicer help here, and maybe we can do this. Maybe add a space there. How about that? That doesn't really display. Little bit tricky to completely get the formatting right, but regardless, we have some cool documentation here that shows us how to add our numbers together. And now if I go through and I do this, we say 2 and 2, we see it's 4, right? Now, since I made some changes here, let's also blow it up real quick. Let's just make a bug. So if I go here and I say var equals, right? Like, so I have a variable that I declared that I didn't declare right. If I try to run this, it's just going to blow up. Now, what I could do is if I do make lint, it'll catch that for me automatically. It's going to say, look, you have a bug on line 25 right there, and in fact, it's an error, right? And you need to actually catch that. And let's go ahead and check this bad code in as well, so you can see the process of why it's so important to do testing. So if I say get status and I say get add main, and we say verifying that a bug is caught with our build system. And this is really critical to test this out when you're first setting up your infrastructure for a project. Is, hey, let's double check that actually the build system is going to catch our bug. And so how do we do this? Well, one of the ways that we can do this is that we can actually go through and go to actions here, and we can say verifying that a bug is caught with our build system. There we go. And we can say install packages, and we go through here and we install these packages first. So that's step 1. And then it will fail when it gets to this lint step, because we know that there's a bug in our code. Now, if it didn't fail here, there's a problem. Great. we like it that there was a failure. And notice it doesn't go down here and check these other parts of the process here. So this is great. So now I know how to fix it. So let's go back to our environment here inside of Codespaces, and let's fix this bug right here. So let's just take it out, and I can, because I like to do the refactor thing all the time, I like to do make refactor like that, and let's clean up my code, and then we'll do a fix. So we'll say git status, git add main, git commit, and we'll say fixing bug, and we'll go ahead and push this. Now that we push this, we go back to this build system. It's going to trigger another build. There we go. And we have fixing build, and it goes back. So again, as I mentioned earlier in the diagram, what the goal is of DevOps really is to continuously improve your system, right? And so the build system, in this case, which is GitHub Actions, is at the center of the universe here, and it allows us to build out an environment that's reproducible, that has testing inside of it, and then it makes it easier to work with other environments. So let's go ahead and take a look at this and see what happens. So again, step 1 would be to install packages, and then step 2, lint, everything works, right? And it's great. And we see actually the history of this. That's the other thing too, is I have a history of every single action that occurred, right? And I can look at all the different things that have happened in my process. So this is really good information for me later to act upon when I'm maybe going back a month and looking at something that happened in a particular project, etc. Right? There's a ton of amazing things here that you can do. So the next thing I think that would be fun to play around with is, let's look in this environment and let's look at the extensions that are available. So if we go here, we look at the extensions that are available, you'll see that I have Docker extension. I have Copilot Labs, which is pretty cool because it allows me to translate code from one language to another. We also have GitHub Copilot Nightly. And the reason why I think for DevOps this is important is, let's read through the documentation here real quick and see what it does. It says, GitHub Copilot uses OpenAI Codex to suggest code and entire functions in real time in your editor, and it's trained on billions of lines of public code. So the reason why this is important is what is the goal? Let's go back to DevOps here. The goal is to continuously improve our process, right? So we could even say, if I go through here and I build out maybe like a tool that can kind of go through, like what is the whole point of what it is that we're doing. Well, the goal is continuous improvement. That is the goal of DevOps. So how do you know if you should do something? Well, does it improve it, right? So there's a word for this called Kaizen in the Japanese culture that applies historically to the automobile industry. But this is really the point. The point is to do continuous improvement. And so if a tool does that improvement, if a tool does make things better, in my opinion, you should use it. You have no reason to not use a tool if it makes your process better. Then you absolutely need to figure out a way to put it into your process, right? And so that's what continuous improvement does. So what it means then for me is that we do need to have this Copilot tool installed inside of here, and we can put this as maybe another color here, and we can say, let's add Copilot or something similar. AWS has a tool called Code Whisperer. It doesn't matter, but it makes things better. We should use it, in my opinion. So if we go back to this real quick into this environment here, what this means is that as I'm building out code, it's going to give me really good suggestions. And so one of the things that we can do really quick is we can see how this could help us a little bit with suggestions. So if I say make test real quick, notice that this calculator library is missing a little bit of code coverage. And so could we fix that? Well, we could. So let's go ahead and let's see if we can have Copilot help us. So what we have here is we say from calculator add, and let's look at so notice that, look, it has add, subtract, multiply, divide. So why don't we just have Copilot help us write out our testing, which again improves the quality control for our system. So we can just do this. We can just say, basically create a multiplication test. So we can just say from import add, subtract, multiply, divide. So multiply test, and it should, there we go, completely build the test for us. And so you just have to give it the right prompt, just like if you were working with somebody at work. It's essentially someone you're working with. Okay, let's build a subtraction, and let's build a divide. There we go, perfect. And now let's do refactor. So make refactor just so it cleans up anything. Okay, and then let's do a make test, and let's go ahead and see if this improves. There we go, 100% test coverage. So really useful, in my opinion, to use these high-level tools. So let's go ahead and say git status here, and let's go ahead and say git add, and commit this. So we'll say git commit, getting to 100% test coverage. And then we can go ahead and push it, and then it's going to push those changes. So one other thing that would be kind of cool that we could do as well is even test even further by potentially testing different versions of Python. They call that matrix testing. And so in our scenario here, we're running Python 3.8. And so this does happen quite a bit, as like people are like, hey, what do I do? Like, I have Python 3.7, 3.8, 3.9. Like, you probably do want to have some kind of matrix testing depending on what kind of stuff you're building. And so fortunately, GitHub Actions does have this. If we go to Actions here and we look at new workflow, we can look at the documentation and see if we can find an example here in the docs. So we could go here, getting started on core concepts, language. Let's look at language guides. Let's look at Python. And if we scroll down here, let's see if we can find matrix on this page. Matrix, there we go. Perfect. So this looks kind of like what we might want here, is something like this, right? So we can see runs on Ubuntu latest, strategy matrix, Python version, and then for setup, we can do something like, so I think we can try this. Let's see if we can build this out and put this into our project. I think this is exactly what we want. So if we go back to the dev container, to the GitHub Actions file here, we just need to tweak it a little bit by putting this inside of here. So I'll put it at the bottom first so I can look at it, and then we'll tweak it. So we see, what is it doing different? So it's run on. So it's got this part here underneath. So let's grab that out and let's put that there. And so we can see in fact, I'll copy it, in fact, so that I don't mess up the formatting here. So let's go ahead and copy this, and runs on. I guess I could actually just copy this whole thing like that, and we could just do that. And we could just put this here. We could just make sure so that looks good, that looks good, that looks good. Okay, that looks good. And then for Python version, we got that. And I think the only thing we need to do is we need to put this under name, under uses, install packages. I think we need to just put, for steps, we need to do that under uses name, set up Python, with. Let's go ahead and try that. So we can do this. Actually, I guess we could even take this part out and add this in. That looks good. Let's see if this will work. We might get lucky here, and let's just double check. Let's get rid of this, And then if I go back to this real quick, it looks like we've got everything there. So let's see if this, we might get lucky and we can test out Python 3.7, 3.8, 3.8, 3.9, and 3.10. So let's go ahead and do make test here, or make refactor. Always a good thing to run, even though I didn't change Python code. We'll say git status. We'll get add.github, git commit, adding matrix step here. There we go. And now, if I go back to my environments, which is right here, DevOps, we should be able to watch it. I'm always skeptical that anything I do on the first try will work, but we might get lucky. So we can see here that it's trying to do a build, and I guess we could look at the first one, the Python 3.7. So it's going to do parallel 4 builds at the same time. I'm not sure though if this project will be able to work on all of these at the same time. Maybe, but it might not. Well, so far that's looking pretty good. So it looks like it might work. Now, if I do this, the status badge, does it show all 4 builds? So it just says it's passing. So it would be interesting if it showed which ones are passing. I don't know if it has a new status badge. Does it have that? Does it? No, it just says default branch. Yeah. I don't know if there's a way to make a fancier status badge, but in general, this is pretty awesome because of the fact that we are able to test even more versions of Python here. Again, we're able to test out 4 different versions. So this is a pretty good, I think, setup here for really getting started. And what that allows us to do is dive into maybe setting up a new environment. So once you've got your core cloud-based environment, then it means that you could hop into any other cloud-based environment. And maybe I'll just, for a second, just before I do something else, just show how that would work. If we go through here and I go to AWS, let's go ahead and see why it's so powerful. If I go to auth here and we say 283, and I go to this and I go ahead and I set up a Cloud Shell environment, we'll be able to see the power of something like this build system, because it means that I can just open up very, very simply any other cloud-based environment and verify that things work. In fact, while this is working, what I can also do is I can also open up Azure. Let's go ahead and open up Azure here real quick, and let's sign into there. Let's do that. And let's open up a shell there. And then maybe we also can open up GCP here, GCP console, and let's go into that. And let's open up a Cloud Shell. And so what's cool about this is you'll see that it's build once, deploy many, right? So we'll move everything here. So we have our GitHub Codespaces, we have Cloud Shell, we have Azure, and we have GCP. And so what does that mean? Well, all we need to do is set up a virtual environment. So in this case, I already have one. So I'm going to deactivate it here. And I'm going to create a new one. We'll just say, let's just RM that other venv here. And let's do rm-rf. And I'm going to create a new one. So we'll say Python 3-mvenv. And we'll put that into here. And I think I have the bash RC already set up. So if I just source it, I can just source the virtual environment like this, bin activate. And now I just go to my repo here and I try to check this out. Just go to local, go to this, go to the Azure environment and do a git clone. There we go. Now if I cd into this, we can just run make all. And this should just magically, everything should work. It should be able to install the packages, it should be able to lint the code, format the code, everything should be able to be ready to run in this particular environment, and we'll see in 1 second whether that's the case. And there we go. So everything's perfect, 100% test coverage. Now if I go to the AWS Cloud, same thing. If I just delete this real quick, the virtual environment, I can recreate it. So we have a brand new one. And then we'll say deactivate. And then if I create a new one, we'll say Python 3-env env. And I source it here, source venv bin activate. There you go. So if I go ahead and I source this virtual environment, now I can do the same thing. I can go over to here, copy it, and then do a git clone here, clone this repo, cd into it, and then do make all. Let's see, does it work? In this case, we actually have the ability to actually do the exact same thing with AWS environment, again, because we have such great quality control with our existing GitHub environment here. That worked perfectly, and we'll see in a second that all the tests should pass. Perfect. And now let's go to GCP, do the same thing. We'll just say Python 3-env env, and let's do that. Let's source it. I might have to, in this case, I might do a slightly different checkout because I don't want to push changes back and I don't want to do any pass SSH keys. I'm just going to do HTTP checkout. So I'm going to go back to here and just say git clone, that's, there we go. And if I cd into here, we can do the same thing, make all, and this should have no problem as well. Now, one of the things that I'll point out is that I believe each of these 4 environments has probably got a slightly different version of Python, and that's where the matrix testing is so powerful, is that there are subtle things that happen, with a certain Python package doesn't do this or doesn't do that, but all of them work here. And so if we say Python, this one's 3.9, right? So GCP is 3.9. If we go to Azure, what version of Python is this? This is version 3.9.14, so slightly different. I think what was the GCP was 3.9.2. And then if we go to Cloud Shell and we type in Python, we have 3.7, so totally different version of Python. And then if we go to this environment, we do Python, we've got Python 3.8. So we have all 4 versions of Python, 3.7, 3.8, 3.9. Oh, no, we don't have 3.10. We don't have 3.10, but our process here is able to test all of them. So really, I think this is my opinion about if you're going to start off with a new company or you're going to start off a new project. I think this structure is really a pillar that you can build your organization off of. I think a pattern that's a pretty good pattern to use is to be able to essentially build once and then deploy many, or build once and use many. And so one of the ways that we could do this is that we could build out a library code, and then we could actually implement it inside of many different environments. And so if we go through here, we can actually talk about each of these kinds of environments. So we could say this could be a CLI, and then this could be the web, and then in fact we could even do another one. We could also just be library, right? So we could also just have a library here that is able to do stuff. And so what's nice about this is that if you use this pattern of you have a bunch of stuff inside of your project where you have maybe your core library here. We'll call this the core library. You can basically divide things up and build many different things out of it. So you could have like a sub library here, and you also could build out containerized systems as well. So if we go through here, we'll build out containerized containers. So that's essentially what we'll do, is we'll just keep building stuff on this idea of make something once and build out many times to many different tools. So let's go ahead and go back to our Codespaces environment here, and with Python, what we have is the idea of putting directories together, and then these directories will hold code that, again, we can actually pull out into these different locations, right? So what we'll do is we'll do the same thing here, is we'll build out some more code that does something interesting. So typically you have to decide, do you want to build it yourself, or do you want to use a pre-existing library? So one of the tools that's kind of a fun one to play around with is Geopy. And so I'm going to go to the Python package index and just look at it real quick. We'll say Geopy. Yeah, so Geopy is a Python client for encoding web services. And if we take a look at this real quick, you can see the documentation that you can do things like geolocate an address. It'll give you the coordinates for it. You can find measuring distance. You can figure out other complicated things here. So this is kind of a fun one to play around with, just to build some toy applications. So I'm going to need to install Geopy. Fortunately, it's pretty easy to do. So I can just go back to my environment here, go to requirements, and we can say essentially third-party libraries for tools, and we can just say Geopy. Now, this is what I typically do when I'm installing a third-party library, is I'll do this. I'll say make install, and then I'll say pip freeze, and then I'll grep for the library I just installed. There we go. So, and I can even put this inside as a pinned version now, like that. There we go. So now I know that we can stabilize on this particular library. And then now that I've got that installed, the next thing that I'll do is I'll create a module. So let's go ahead and do that. So we'll call this maybe GeoTools. So we'll say mylib geotools.py, just like that. And so now that we've got this GeoTools set up, the next thing that we can do is start using some of the advanced technology that we have at our fingertips to build this out. So I'm going to first start off and build the template for what it is that I want to build. So I'll go ahead and say build a library of geospatial tools. Yeah, it looks pretty good. And so the first thing we'll do is we'll import Geopy, like that. And then here's where this is where a tool like Copilot can really be helpful, because I can start to essentially ask it questions and interrogate it and direct it to help me build out boilerplate code, which there isn't necessarily anything unique about building boilerplate code. So I'm going to use this advanced tool to do it. So one of the things I could do is I could say create a function that returns a list of the 10 most populated cities in the United States, in the USA. There we go. Populous cities. And what's cool is it'll actually build out some boilerplate code for me. So again, I mean, am I cheating because I'm using this? I would say I'm being smart because I don't need to write this boilerplate code. I can let this tool write it for me. And so now if I say make refactor, this is where the feedback loop really comes into play, because look, this code is not is kind of dirty because it's going beyond 80 characters. Now if I refactor it, watch, it'll clean it up. It says, uh-oh, unused Geopy. Well, let's fix this real quick, and then we'll run refactor. So it should have. I think we need to change. Oh, we need to change the Python black tool to look inside of this directory. I was like, why is this not refactoring? So pretty easy to do. We just go here, and we need to tell Python black to also look inside of my lib here. There we go. So now we can do that. GeoTools, and we can say make refactor. Perfect. There we go. Now it refactored our code. So not bad. And now let's take this Geopy import here. And so now that I've got these 10 most populous cities, I'll show a tool that I typically use when I first start programming. Is that notice in our requirements file that I don't have access to IPython, and I like to use IPython as a tool to just play around with objects or play around with like modules as I'm building them. So I'm gonna call this basically maybe a different section, and we'll call this like maybe up here, and we'll call this development tools, right? And so it's always a good idea to have maybe categories here where I can look at things so that I know what it is I'm building. And we'll do the same thing. We'll say IPython, and now I can say make install, and we've got IPython. Great. Now that I've got IPython here, what I can do next is do that same process. I can say pip freeze grep IPython. Here we go. We got IPython. Let's pin it so I know I have the exact version here. And so now what I can do is I can actually start to play around with this library to make sure that I understand how it works. I think it's always a good idea to do that. So we can do that. We can say IPython, and we can say from my lib dot geotools imports get populous cities. And now we can say cities is equal to get populous cities, and we can do cities. There you go. Right, so we know, okay, that looks pretty good, and if I want to slice it or do something with it, I've got it, right? So I always think that's a good idea to get something like that cooking, so that in the future now I can interrogate this library as I build it. So now what we can do is we can write something that is able to get the distance between two cities, right? And so we can exactly create and that's what's kind of fun about Copilot, is it typically can start to anticipate some of the things that you may want to do, just like a real person. And so we can go here and we can say, okay, get distance between two cities, and let's just take a look at this. So it says return the distance between two cities, create a geolocator, get the location of city 1, city 2, user agent, my application. I think for user agents, I'm going to tweak it. So, and it's okay to tweak it a little bit as well. And I don't know what that means actually. So I'm going to look at the documentation real quick for this. I'm going to go to the documentation real quick. And if we search for that, I'm just curious what this does. Oh, it's been moved here what does this do? Is using it with the default user is discouraged. Please make sure to build a custom user agent. Okay, so it says don't do that. All right, we won't do that. So I'm going to go back here, and I'm going to create in maybe like a global variable could be a good way to handle this, and we can say here user agent, and then instead I'm going to say Python for DevOps tutorial. There you go. And we can go through here, and we can just put in user agent. There you go. Right. So now I've got that user agent there, and this looks pretty good. If I do a make refactor, so I think this is critical to use refactoring while you're using a tool like Copilot. Let's go ahead and do make refactor, and there we go. So we have nice clean code here. So then I would again do the same thing that I did before. Is let's open up my Python. Let's import these two functions. Now let's import get distance. Perfect. And now we can say we can grab these cities. So let's go ahead and do cities here, and now we can just call this function with two cities. So we can say essentially the first city and the second city. So we can say get distance, and we can say cities index 0, and then cities index 1. And it's going to find, so Geopy has no attribute returned. So we might need to clean this up a little bit. It says module Geopy has no attribute distance. Import Geopy. Distance. So we can play around with this. So we can say import Geopy, and we can say Geopy dot distance. So it doesn't appear. Or we can say from Geopy import distance. How about that? And then if we say distance, is it distance.distance? Maybe you have to import it that way. So let's try that. So maybe we can say from, we can change the import. So we can say from Geopy import distance and geocoders, and then also geolocator. Point. Do we need point here? I don't see point. Geolocator. Or is it geolocation? Geocoder? No, geolocator. See, this is import geolocator. Yeah, where's that coming from? Yeah, so this code is a little bit it's close, but not exactly. Oh, I see, geolocators there. So we just geocoders is what we care about. So we want geocoders. I think just geocoders and Geopy. Like that. Let's try that. And then we can change this to do that. And then we can try this, and let's see if that works. So what we can do is we can do exit, and we can say make refactor. And now if we try this again, we can play around with from my lib .geotools, import those two, import get populous cities, get populous cities, and get distance. Get distance. There we go. And now we can say cities is equal to populous cities, and we can say get distance, and there we go. Okay, we got it fixed. Right, nice. And so what we can do now is we have enough that we could start to turn this into a command line tool. So that's typically what I do, is first start with building a little bit of logic, make sure it works. We could also write a test for it. Why not? Let's maybe build a let's build a test here. So we can say from my lib dot geotools import get distance and get populous cities, and then we can just have it build out some tests for us. So we can say create a test for get distance New York, Los Angeles, sure. And now let's do make test. Looks pretty good. All right, so that's what's kind of cool about Copilot, is that you have to watch it, but it definitely can speed up building boilerplate code. And so now I'm going to call this basically GeoCLI. So we'll call this GeoCLI, like that, GeoCLI. And then from here, we can do something similar. We can just put first the shebang line. So user bin env Python, and then we can do here a command line tool interface for geospatial tools. We can say even a few more things, like uses the click library. There we go. So now we can say import click. We can say from my lib. Exactly. Let's import those two libraries. And then what I like to do is build a click group so I can do multiple tools. And then we can build a command. So the first one would be basically distance right here. So we can build a subcommand that does distance. This should be pretty easy. The code will essentially write itself. And so we would do some argument city 1, argument city 2, get the distance between the two cities. It's just going to do the same thing I was doing before. Now, I probably want to clean this up a little bit and add some more bells and whistles to it. So we'll say get the distance between two cities, and we'll say example. Right, so we'll add an example here, right? And I can just change this like that. So that looks pretty good. And if we go back to GeoTools, let's double check. Yeah, okay, so that works. New York. Okay. And we can also we can print the distance using different colors for cities and distance, right? And so you can also prompt it to kind of make it a little bit like fancier. There we go. That looks good. And we'll also need to invoke this. So we can build another subcommand that will do cities. So in this case, this will get a list of the 10 most populated cities in the world, just so the user can get access to it. And yeah, it looks good. And then now we can do, exactly, we can invoke it. So it really does do a lot of the work for us when we're building out a tool. And we can do this, GeoCLI help. There we go. So we have a help menu here, and get a list of the 10 most populated cities in the US. So let's first try that one. So we'll do cities. Let's first make this, clear the screen, and we can do GeoCLI cities. There we go. We have the 10 most populated cities in the US. And now if we want to do the distance, what we could do as well is make it even easier to use by doing defaults. And we can say type string defaults is that, there we go. And so let's just make it kind of easy to use by doing distance here. There we go. New York to Los Angeles is 24, 50, 86 miles. There we go. Not bad. Not a bad little tool to start with. And then if I say make refactor, we clean everything up, make it a little bit better. Now we can clean up bugs that we put into our code. So one bug we have is on line 26. It says redefining distance from. So this is, yeah, we don't want to necessarily have the same name here. So what we can do is we can say distance CLI, and we can do underscore, and then the other one is cities. We can say cities CLI, and we can make it refactor so we don't use the same variable names. Looks good. Now if I do make test, we can see that we have some okay things here, but this, we have a couple of things that are interesting. One of them is that we have this weird Geopy thing. So we may want to be careful about how to test out Geopy, right? So if we test it, it may time out. So we can say, so maybe we want to not test that programmatically. So if we go back to our test here, if we just say one failed, one passed. Let's Google this. Let's just say let's do this, and let's see what we can find out about this particular bug. PyTest. I got an error when I do this. That means you reach a timeout. Oh, I see. So you just have to do a timeout. I still get the error with the speed of the connection for it to rate limiter. Oh, I see. Geopy has a rate limiter which provides a convenient way to deal with too many requests by adding delays between queries. So that could be an issue, the rate limiting here. So just to not deal with that, what I can do is I'm going to take this test out, because we can kick that can down the road and let a more complex solution solve that. So I'm not gonna worry about that one. But what we can do is just make a refactor here and go from there. So I'm gonna go ahead and check all this in, and we'll have this, and we'll say git commit adding Geopy library. There we go. And what's nice about this, if we go back to GitHub Actions here, we now have the ability to watch it work, and we can again see that the matrix testing will work. So we don't know yet. Will it work on these 4 different versions of Python, right? Will it work on Python 3.7, Python 3.8, 3.9, 3.10? We'll find out. So look, we did spot something, right? So there is a issue that we're able to find, which is pretty cool that it was able to identify that. Let's see what the problem was. Oh, so IPython this pinned version, there was a problem with Python 3.7. So that could be an issue for us. And in fact, what we could do is maybe change that pin. It's, there's no perfect answer for this, but if we did this instead of it pinning, like, because Python is optional, we don't really need it. Like, we could even put like a note that says like, you don't need these. You don't need these. Is that we could do this. We could say, you don't need these for deploy. So in that case, so pin doesn't matter. Pinning doesn't matter, right? So in this case, this is a superfluous tool, right? We can just do IPython, and then it'll just grab whatever one it can find, which is nice. It does tell us basically the strategy. So if we say make refactor, get all that going, that looks good. And we say get status. We add this requirements. We commit this, adding in the unpinned IPython. All right, let's go ahead and check this out, and let's see what we can do inside of this repo. Okay, so we're seeing things maybe are getting better. If we go to 3.7 here, we see install packages. Hopefully it doesn't blow up. There we go. So looks like this is going to work. So again, our automated testing has really been a huge win for us in order to get this. So what we can do is keep building more logic, right, inside of our library here. And I think another thing that would be kind of fun to build out would be to, let's say we're building a library that let's say we're working at a travel company, and we'll say this library is used by a travel company. So we also potentially could use, we could also build something that lets us find out information about the regions, right? So we could build another library. So we can go here, we can say touch my lib, and this we'll grab the Wikipedia page to get some information. We'll call this wiki here, and then we'll go to requirements, and we're going to add Wikipedia. And so we can do that. We can say make install. Wikipedia is using legacy. Okay, so we can say pip freeze Wikipedia. And now, there we go. Wikipedia is equal to 1.40. Perfect. Okay, so now that we've got Wikipedia inside of here, the next thing to do would be to start to integrate a library around this. So we can essentially put some notes here at the top and just say, build, build a library of Wikipedia tools. There we go. And we can say import Wikipedia, create a function to return the summary of a Wikipedia page. That looks good. And then create a function. We'll do this. We'll say create a function to search, a function to search for a Wikipedia page, to search for a match, for the best match for Wikipedia page. So search term, and we can start with that. That might work. And so what we could do is, again, use IPython to help us out. First, let's refactor. So make refactor. And then we'll say IPython. And we'll say from my lib.wiki imports everything. We type in who, that'll show us the things that are loaded. And we can just say get wiki page. Well, we also, what I want to do is I want to say from my lib.geo, I want to import these real quick, and I want to say cities, exactly, is populous cities. And so I want to pass in to get wiki page, the first city. We'll say get wiki page. Get wiki page is not defined. Oh, because I spelled it wrong. There we go. Get wiki page. There we go. So Wikipedia page, that looks good. Dot text, or what do we get out of this thing? Is it content? So this is why it's so nice to play with IPython, is we can interrogate the object that comes back. There you go. That's probably what we want, is the contents, or even the summary as well, which is another one. So if we say content, how long is this? We can say len, and we can do this. It's a pretty big page. Return the page. Oh, and that's the summary. Get the Wikipedia summary. And this is the, in this case, that's the full page. We can just say, in this case, we can do content. We can just get the full content in this scenario. All right, so now that we've got that, the next thing that we can do is actually use a tool to basically categorize what's happening. And one of the ways you can do this is actually do some searching. So find like key terms in a page, and a tool that I kind of like is called Yake. So I'm going to do that. Here we go. So single document, unsupervised keyword, learning. So this will basically grab keywords out of somewhere. So we just want to see like, hey, what can I do in New York, for example? And so in order to install it, I should be able to just throw this in there like this. And we can go to requirements, and we can do here just like that. So let's go ahead and do make install like that. Okay, so now what we can do is go to Wikipedia, and we can say import Yake. And what we can do is do something similar to this. Like we have a bunch of text, and we just do, we grab the keywords out of it. So let's do that. So let's go here, and we'll say create a function to return the keywords of a Wikipedia page. And that looks like close Yake, and let's double check how Yake works again. It would be this, we'll do that. Yake is equal to keyword extractor, and we'll call this, it'll be the page. See, in this case, we're returning back the page, so we don't need to do page.content. Return the page content there. Okay, Wikipedia page content, like that. Okay, and then return the keywords. There we go. So let's try this real quick. And we'll say here, and we'll say from wiki, from my lib.wiki, import all. There we go. And then we want to say keywords, or we want to say cities first, right? So that's the cities. And then we want to say essentially get wiki keywords, and we can put in the cities there. Oh, it says object of Wikipedia has no len because Wikipedia page has no len generated the following text. Page let's try to do that. Let's just return back page, return back the page. So we could basically just recreate this really easily, because we could first do that. We could just paste this inside we allow, right? So we could do that. We could say get page content, and we could say results page is equal to get wiki page content, and put in the cities 0, and now we have page. There we go. And we say page.content. That's so now we can just say keyword extractor. So we can say from Yake, or import Yake, keyword extractor, and then in this case it would be page.content. And so let's try that. Keywords. There we go. So we have keywords right there. So we could, basically return those as a tool that allows someone to get some ideas about, hey, what can I do in this city? What are some cool touristy destinations or something like that? So it looks pretty good. So I'm going to go ahead and refactor this, make refactor. Let's clean up the code. Looks good. And now let's put this into GeoTools here, and let's say, let's put this into the GeoCLI, and let's just say from my lib.wiki, let's get wiki keywords only. That's the only one we really care about. And so what we're going to do is we're going to say basically create a command to get the keywords of a city of one of a city. There we go. So we'll say keywords. There we go. Default New York. And we'll say get the keywords. Yeah, it looks pretty good. And let's say make refactor. Looks pretty good. And let's go ahead and try it out. So we'll say GeoCLI keywords. There we go. Not bad. So it's able to find the and we could even clean these up, and we could even like make like a little function to dedupe and rank it. So we could even build out here. We could say like build a function to deduplicate keywords from a list of keywords, and okay. And so we can basically then go down here and we can say limit, we can say limit to 5 maybe. No, we're going to say keywords of a city by default only return the top 5 keywords. So we're going to do this here. We're going to just clean this up real quick. And we're going to say at click option top 5, and we'll say top, and we'll let it clean it up a little bit. Default is 5, and then deduplicate. So get them, deduplicate it, and then give us the now. Yeah, sure. You could clean this up a little bit more, but this is good enough. So we'll just say keywords. New York City subway, New York City population, and then we could say basically only print out the text. So only print out the keyword and not the score. There we go. So if we go here, there we go. York City subway, York. Now we probably had to clean this deduper up a little bit because it's not exactly doing exactly what we want. We want to say create a function that dedupes phrases. There we go. Create a set of phrases. Let's see if that dedupe phrases is better. Dedupe phrases. Doesn't need to be perfect. Dedupe keywords. Oh, deduped phrases. Deduplicate phrases. There we go. Well, we can even be sloppier and just do this. Regenerate the code. There we go. Unexpected. So we can refactor. And it cannot do line 70. Oh, because it for some reason, put everything, indented it for no reason. So we can just clean that up. Now we can refactor it, and we can rerun it. There we go. York City Global. So I don't know why that part is having issues, but it's better. It's close enough, good enough. So we'll say git status, and we'll add this into our code. Adding a tool for traveling. And we're going to go to the next step, which is web app based container that gets deployed to a platform as a service offering. And so the idea here, again, is you have a cloud environment that solves a lot of the problems for you. You then build out a container. That container can be deployed to multiple different cloud providers. And so the trick is going to be here is that can you actually programmatically push that container into a container registry and then have some kind of platform as a service deploy it automatically. And so that's what we're going to do, is we're going to start off with doing this with the AWS platform. But I'm going to first start with finishing this out and just making sure that I've got a complete working container. Then I'm going to move over to AWS and finish a couple things in a cloud-based development environment and then go from there. So to start with, what we can do is actually fully flush out our API. So we know that we have some library code that does some cool stuff. So I'm going to go here. I'm going to say from my lib GeoTools imports git distance would be one, and then also I think we can import the phrases here as well. Oh no, we can get that from the wiki library. So we can say from Wikipedia wiki keywords. We want to get wiki keywords. We want to do that, and we also say we want to do get wiki keywords. We want to do that from Wikipedia mylib.wiki imports get wiki keywords. There we go. Now we may want to move some of that dedupe code if I wanted to use it, but for now I won't bother with that. But I'm going to make a new method right here that says that basically returns back the distance between two cities. Actually, and let's also get the cities. I forgot the cities here was populous cities. Get populous cities. There we go. So let's first make the populous cities one. So we'll say build a route that to return the 10 top cities. There we go, cities. Okay, perfect, that looks good. And now let's build another one that the distance between two cities. Now this, we will need to, we want to change this to either parameters or something like this. We can do, there we go. Let's just do parameters. Nah, parameters actually could be messy. So we're going to change this to a post request here. So we'll do this post. There we go. And get distance. Let's regenerate this code. Get distance between these cities here. All right, and then the other one we can do is get the phrases. So build keywords from Wikipedia page. So keywords. So get keywords from a page. Okay, so this looks pretty good, and I can do refactor here, make refactor, and we have some things here to fix. So line 22, we can say get cities route, and we'll just change these to be a route. And keywords route. There we go. Make refactor. Looks good. Now if I run this, we can test this out in the browser. And if we go to /docs, this will give us the Swagger documentation, which is pretty nice. So we can just first get the cities and try it out. There we go. So now we can try LA here, and we can try the keywords. So what is it going to take? It's going to take a string, just LA, and so the URL will be that. There we go. So it was able to actually take a very basic post request that shows us some cool keywords here from that result. So not bad, not a bad little web service here that gives us some cool things to look on. I mean, I guess we could do something even a little bit fancier, which is we could we could clean it up, but I think for now this is good enough. Okay, let's go ahead and now that we've got this thing working, is test it out in a container. So we can do that. So we can say docker build dot. This will build out this container. There we go. And then we can look at history, and we can just take one of those other runs here, like this, and we can say docker image ls, and we can say docker run, and then we can take the last one that was just built, which is this one, and we can try it out. So we can go back to this, and we can do /docs. There we go. So now we have cities route, distance route, all this stuff. We can try the keywords again, and we can say try it out, and we can do, well, first let's get the cities so I can grab one of them. Let's do Houston, Texas here, and then we can do keywords. There we go. Houston, Greater Houston area, airport system, Space Center Houston. So this basically gives somebody that's traveling some ideas of maybe some things they could visit when they're going to a particular city. All right, that looks pretty good. So we've got this thing working. So the next step here is I'm just going to check all this in. So I'm going to say make refactor, and then I'm going to say get status, get add all this, get commit, adding working FastAPI, containerized app. And what we can do next is move on to a different cloud platform. So I'm going to shift gears to using the AWS cloud now. And so what we can do is use their cloud-based environment, which is Cloud9. And so it's very similar to actually GitHub Codespaces. And I'm going to just make a new one really quick here. And I'm going to call this one a FastAPI container environments. And we'll just say this is for deploying and testing containerized applications to AWS. There we go. Now we can pick a machine. I typically like, at the very least, a large machine here, just so that it'll build quick. But you can even build even bigger. Since this isn't too hardcore, I'll just use this one, and I'm going to go ahead and say create. So it's going to create this fast API container, and we can click on this while it's actually building, and get this thing cooking. So I'm also going to need to get the the GitHub credentials hooked up here, and so I'm going to need to go back to GitHub and get the URL. So let's go to here. Let's go to this DevOps repo. Let's go to SSH, and we'll go here. So once this thing wakes up, then I'll be able to do a git clone. Now I will need to put my SSH keys in first. So again, this looks kind of similar, right, to Cloud9. It's got a lot of similarities actually to GitHub Codespaces, but I'm going to need to set up SSH keys first. So SSH first, let's just do that. Let's just put that in there, and we'll say SSH keygen -t RSA, and then I'm going to cat this key path, this one, the public key. There we go. I'm going to grab this and put this into GitHub. So we'll go back to GitHub here and put these keys in, because I'm probably going to push code as well as pull code. And we'll do this, Cloud9. All right, we'll do this. I got to auth my GitHub account. Let's go ahead and do that. Okay, and now that's set. And now I can do a git clone. So git clone of this. Git clone. There you go. And this should work. Now the first thing I'm going to do is I'm going to create a Python virtual environment. Python 3 vn. There we go. And now let's go ahead and put this into the bash rc file. So at the very bottom here, we can do that. We can say source venv. So we'll say source this activate. So now once I save this, and we just can open up a new shell, right? So we can go here, new terminal, get rid of that terminal. We got this, and then if I cd into the this repo, we can just say make all, and this should work. All right, we're all set here. Now, if I go to AWS here, let's talk a little bit about why it's a cool environment. So one of them is that it itself also has a code completion tool. And so I have enabled it here. So that's kind of cool. We can use that. We also can explore basically different environments here as well. And so if I wanted to integrate with the repository for containing containers, I could actually create a repo right here, which is kind of cool. I also can interact with App Runner as well, and I could also create a service for it. So there's a lot of really cool integrations that you get that are unique to AWS by using the AWS Cloud9 environment here. So we'll touch on some of those in a little bit, but let's just double check that everything works here. So if I just type in Python app, right, does it work? It should load this thing. And then if I click on preview running application, look, we can actually play with it right here, and we can go to docs and we can test it out, right? So we can also play around in a similar way in this particular environment. So the next thing that I'm going to do is I'm going to go to the this process and get a new container registry set up. So how am I going to do this? Well, let's go to AWS and let's do it first with this tool. So I'm going to say create repository. And if I go into this repository, we're going to call this one FastAPI. Let's not call it just FastAPI. Let's just call this GeoService. How about that? That's a better name for it. Kind of less generic. There you go. So it created a new service called GeoService. Now, what's cool about this, if we go here, if we go to GeoService, is that you could actually create a service for App Runner directly from this thing, which is pretty cool stuff, right? Is that I don't even have to do anything. It'll just create a service automatically for me. So let's go ahead and try that. Let's click on create App Runner. But before I do that, what I want to do first is that I want to push my container to ECR. And so how am I going to do this? Well, let's go over to ECR here. And we should be able to see it, Elastic Container Registry. And all we need to do is find our service. There we go, GeoService. And check this out. We have view push commands. If we go to view push commands, these are the commands that we need in order to deploy this. And so really it's just the process of taking the container and pushing it into a container registry. And so in this particular scenario here, we can just basically put these into our Docker file if we want to be really lazy. And I do like to be lazy. So what I'm going to do is I'm going to copy this and just do it step by step. So let's go to our Docker file here, or our make file here, and we'll say, let's fill out our build step. So notice here, this is our build step. So let's now put this inside, and we'll put a note like build container, which does deploy, which triggers deploy. Yeah, and so this is definitely pretty slick, because essentially the whole deploy process will just be pushing a container. And so now we do the next one. It would be kind of nice to clean this up a little bit, maybe to do this here. Actually, hopefully that I didn't mangle that too bad. Line breaks are always a pain to deal with. If it's a problem, I'll just put it back to one line. But we'll go to this next. And so we can say essentially auth, step 1, step 2, build, step 2, build. And then we can go to step 3, which is tag. So step 3, tag. And I think I could do something similar here if I don't mangle it too bad. And then we can also do step 4, which is push. Step 4, push. And we go back to this and we copy this command. Whoops, here we go. So in theory, if I didn't mess up the line breaks, this should be essentially pushing it to that repo. Let's try it out. Now, one thing, yeah, let's just try this. So let's go ahead and do make deploy. And wow, I got all the line breaks right. I'm just shocked. It's always easy to mess that up. So it's using our service here to push there, and it should be very fast to push because it's in the same region, right? We're probably in the same data center, pushing this directly to wherever the container registry lives. And this looking good. Okay, so we got this thing pushed into the right location here. And then if we go to the container registry, if we refresh, now we have a container. Nice. So in theory, if we go back to AWS here, we should be able to go to ECR, find this container registry, right click and say create app runner service. Let's try. So it says enter port 8080, okay, and then it's going to say configure. We can say skip, select an IAM role. Sure, we'll select a role. So this would be basically a role that would allow us to pull from the container registry. We can name the service. We can call it a similar service name, GeoService. Let's do that, GeoService. And then we can pick what kind of instance. This is a very small machine. We can just take a one CPU. So pretty cool actually is that if we go to App Runner, look, there we go. We can actually see that this service is actually in the process of being created, right? So we can even look at the log stream and check it out and see exactly what's happening. So we can see the App Runner is starting to pull here. So very nice integrated thing where I don't even have to leave my IDE, which is what I want, right? It's a very cool setup here. So let's go ahead and go over to App Runner real quick, and let's check a look at this. So GeoService, we can see that it's running, and it's going to be deploying this into this location. So what's really nice about this is, in terms of App Runner, we can just take a look at what the App Runner service does in general. Is that it has the ability to hook up with GitHub, network configurations, all kinds of stuff, but it's a hosted service that's end-to-end, so a platform as a service that handles really the entire process of everything you would need to do in order to deploy an application, from giving you an encrypted URL that's publicly exposed to also adding lots of metrics and observability, so you can see like who's making requests to it, service counts, things like that. Also, you can turn on tracing. You can even hook it up to a custom domain as well. So you could hook it up so that it has, like basically a fully qualified domain that's your own offering. So really kind of an end-to-end solution here. So while this thing is spinning up, the other thing to keep in mind is I could show you like an existing service. Like here's one that I had set up a while back. That's a machine learning application, and if I click on it, you can see there we go. It's running Hello World application, and if I wanted to go to some docs here, there we go. We can see that this is also a FastAPI application that I believe does a prediction based on like an image, like if I put a cat or dog or something like that. And so we could just try it out real quick. I think I have like a cat picture or something like that locally. So let's go to desktop and let's go to cats and dogs. Cats, there we go. There's some kind of a cat. Let's put this, execute it. There we go. It was able to successfully predict. So you can see like this is just some service that I could expose to people, and it's doing machine learning. It's doing all kinds of fun stuff, and it's hosted directly into this environment. And if I look at the activity as well, that we should under the metrics, we should be able to see like essentially all of the requests that are being made to it, the successful HTTP responses, and as well, we can even look at the logs. If we go to application logs here, and we should be able to see that request that I just did. And so we can look in this, view logs, run query, and we should be able to see all the different things that are occurring. Here we go. There's the post request that I just did, and then it return back the response as well. So a very nice end-to-end service that does allow you to build out things very, very quickly. So if we go back here, this thing should be close to being finished. There we go. Yep, it's almost done. Performing health check on port 8080. And we can probably use it in a second. It should be really close. Health check, because I think once the health check is available, then it's good to go. I think though that this might mean that I can just click on the link. Nope, not yet. I think first it has to do the health check. Once the health check passes, then I believe the service will become active. So refresh here, deploying to GeoService. Nope, still not working. Those will take just a second. But you can see the process is step one, create the service, which we did inside of Cloud9. 2, make it operational. 3, pull the image from ECR. Create a runtime, so provision the instance, and then once the instance has been provisioned, then do a health check. And so I guess the health check here is taking a second to run. And once the health check is passing, we should be able to see it. So it's still in create service. And we can look at the application logs. There we go. It looks like it is actually running. So if we go back here, does this work yet? Oh, there we go. So it is active now. So now if we go to docs, we should be able to run our service, and we can look at the cities first. Let's go ahead and grab these cities. There we go. We have these cities available, and we can do a new city now since we've done other cities before. Let's go to the keywords. Let's grab the keywords from this. San Diego. Perfect. There we go. We can see San Diego Bay, San Diego State University, Mission, San Diego, downtown, San Diego International, regional, public, etc. And we can take a look at all this. Perfect. So we got it. We have a full working service here now. I would say this is good, but it's not great yet. And we can make it great by also doing continuous delivery. So why would we want to do continuous delivery? Well, if we push a new image or a new change to our code, then we could fully get continuous delivery set up. So how would we do this? Well, fortunately, it's pretty easy. All we need to do is go to the build system that's available on AWS. You could use GitHub as well, but if we just go to the build system available here, which is called Code Build, build and test code. We just create a new build project, and we'll call this one GeoService, and this builds the GeoService container automatically, right? And so then when I make a change to the service, this will automatically push a new version there. And so I can even trigger it from GitHub, because this will just listen to GitHub. So we can enable a badge. We can also choose where we want the events to come from. In this case, we'll pick GitHub, and it'll go to my GitHub account, and it'll populate a bunch of different services, and then we can find those services. They should be here in just a second. Okay, this should be populating pretty soon here. And so now we can just search that DevOps to 2023 project. Perfect. And now we just say, yeah, I want to rebuild every time I make a change, so that'll do continuous delivery. And then here's where we could build, what is it that we're going to build in? Well, let's build it inside of the same kind of environment that it'll deploy to. So we use Amazon Linux. We'll pick the standard runtime. Let's pick the latest version of Amazon Linux. We do need to do this because it's going to build a Docker image. And then here's where a lot of people will get tripped up, is you have to create an IAM role inside of your account so that you have the privileges. So I would recommend an admin role typically for my build system, and then maybe you tune down the privileges later. But to get started for debugging, I think it's good to do an admin role and then assign it to Code Build. Since I already have one, I can actually pick one right here that is an admin role. And then this is the only other thing I need to do is, well, do I want to use a build spec file, or do I want to do a build command? I would say a build spec file is probably better for this. And the build spec file is going to be pretty easy to create. In fact, if we go back to our environment in Cloud9, which is right here, we can just build it real quick. So we can go over here and we can just say touch build spec. And I can even find one that I've got inside of one of my accounts. We can just look for build spec.yml, and we can look at build spec. We probably want to do only build spec. We want to look just in my account for build spec, and I should be able to find one that's a really simple one. For example, I think it might actually be in the FastAPI repo that I have here. FastAPI from 0. I bet you have a build spec. Yeah, here it is. Build spec. We need like a really, really, really simple build spec. Almost nothing. And all it needs to do is make all, because we know that we've already done all the hard work. So if I go to the repo right here, let's double check the name of it again. It's called build.yml. Buildspec.yml. And we just paste this in. That's it. That's all you have to do to build the build spec. And so I'll go ahead and say get status. Now the make file, did we really modify that make file? Oh, we did modify the make file, that's right. So let's say git add everything, git commit, adding a new make file, and build spec. There we go. And I'm just going to push this because I don't need to put those changes in there. And now that I've got that, if we go back to code build here, I can assume that the build spec has been created. And I believe that's it. We just create the build project. Now, because I haven't made a change yet, it won't build, but the first time it will build. And so a couple things to point out here is that now it's up to me to decide what, how do I want the build to work. Now I could go back to my environment here and just do a git pull to pull the changes. And now if I want to trigger the build, anything will trigger the build. So we could even put in like the new template, which, did I grab that? I think it's something like this I have to do, which is you do I actually don't remember the exact I don't know why they make it hard to do the build here, but I believe that I had a build badge that I can just copy from FastAPI from 0. Let's see. No, I didn't have a build badge there. Anyway, I can just put something else here for now. We'll just put push build, push build, like that. And then if I say get status, we can see there's a README. Commit this, adding a change to build. There we go. So this should trigger this build system now. So let's see here. If I go here and I click on build, there we go. It's been triggered because I pushed a change. Any change from any machine that has access to the GitHub repo will then push this in there. And so this in this particular scenario here, that's exactly what's happening. And what's cool about this is we can even look at the logs, watch the entire process. And now what's interesting is while this is running, if we go back to App Runner, notice that App Runner, nothing's happening yet. It works. We see everything's it's set up, it's running, because it's not going to trigger a build yet until this build server pushes the container image to the repo, right? So once the Docker image has been pushed to the repo, then it will actually trigger the build. So let's just wait for it, and we can see that it's building the whole thing. And again, the all, if you remember, is basically leveraging the fact that it's just going to push it to ECR. So here we go. It's building all this stuff. This looks good. All right, so it's now going to push this container. There we go. So now that the container has been pushed, let's go back to the service here. And if we refresh, in a second, it might be able to do auto deploy. So let's double check here. So I know what the issue is that we need to change this service to be able to do continuous delivery. So that's one thing that we didn't do, I believe. See, look, manual deployment. That's the issue. So it won't listen to the container registry yet. So we can fix that though, because we say, look, App Runner monitors your registry and pushes a new version each image change. So let's go ahead and do this. And we can say uses existing role. Perfect. There we go. So now it's updating it and it's going to deploy automatically. So if you do create that from the Cloud9 environment and you do want to do continuous delivery, you just need to make that change and then it'll do a continuous delivery of that service. So pretty awesome that you can really quickly set up this whole service that again is really if we go to this diagram here, you have the cloud environment, you have the container, you get it built automatically, you can push it to all these different services. In this case, it's AWS. Now we could try as well to try really briefly to deploy to another environment, like for example, this environment. And so if I go here and I go back to this repo here and we just reconnect, one of the things that we could do is we could see if we could run do a deploy to their service. I think it's called Cloud Run is their service that does something kind of similar. And I believe that all it needs, if I say git, we just need to do a git pull real quick. And let's see if we can do something similar. So let's go to repository here. And let's copy this. And let's go to here. So put these all together. And let's just do a git clone. And we can clone this thing. So it's going to need SSH keys. So we can do a clone via HTTP. So let's go to HTTP. Copy. Git clone this. Okay, so if we cd into here, if I remember correctly, if we say Google Cloud Build, Cloud Run, I think it's just one command in seconds. Yeah, so documentation, let's try this real quick. Where's the docs here? Docs. And let's type in Cloud Run v2. Let's see if there's service quick start. Here we go, quick start. And so go to project, go to test it, go to Cloud Run, create a service, test with sample container. There's another one, deploy from Git repo. That's what we want. And so Python, we go here. So you go to Cloud Run, updating service, build and deploy Python. See if we can figure this out. Make directory, we go application, we have a Docker file. Yeah, this is all I need to do. Sorry, it took a little bit to find this, but here we go. I believe I just run this one command. Do Cloud Run deploy. Does it work? Sure. Oh, do deploy container, use image. Let's do that. So let's deploy container. So -- image. Oh, wait, deploy. It doesn't really matter because it'll deploy from source. Well, it's essentially the same thing. We can make it do it either way. We'll authorize it. And then from here, this will essentially do exactly the same thing. Let's just say, which region do we want to deploy to? We'll say US East 1, do 28. This image is equivalent to doing this, and gcloud deploys allow, sure. There we go. That's it. So it's essentially a one-liner on another cloud platform to do. And look, you can see it's building it's building the container for us automatically and pushing it to there. So once you've got this essentially like a sourdough starter kit, you can make bread on lots of different platforms. And that's what's really cool about getting this set up is it really is a pretty cool way to build services, is, step by step, build out a containerized service and then test it out, get everything working, and then you can deploy it to a new environment. So while this thing's running, this won't take that long. We can, if we want to, look at the log files here. So we can do that real quick. Let's see if we can find those log files here. And you can see here, look, it's doing all the stuff here, which is kind of cool. So it's using their cloud-based system. So it's similar, right? You can see the concepts are very, very similar between the different cloud-based environments. And so it's going to go through here. It's going to build the container for us automatically. And we can watch it do its work. So it's actually kind of fun to watch how different cloud providers have very, very similar concepts. And once you understand the concepts, it's easy to apply those concepts to new environments. And we'll keep going. We'll keep going. And now it's pushing this into this environment. It is neat that it's going to push this, the source of the build, into this Google Cloud Storage bucket as well. So it looks like it now was able to build this, build step 1. And if we go back to the service, we can say it's built. It shows us exactly where it's at. In this case, building container. I guess it's taking a little bit of time to push this thing up. There we go. It's done. So that step's done. Now, once the container's built, I'm assuming it's going to then route the traffic next. So it should be pretty close. Yep. Okay. Building container. It's done. Now it's on creating revision. Which I don't think there should be a revision. I think it should go pretty quickly. I don't know if there's any other things. I think this is done. I don't think there's any other services to do. Yeah, that's it. There's nothing else to look at here. So we can just kill that window. Creating revision. Okay, there we go. Now it's setting up the security policy for this thing. And it'll be kind of fun to see the exact same service deployed in a brand new environment. I don't believe it's doing anything tricky, so it should just work with a one-line change. Now I believe, there we go. So that looks like that's done. And I think as well, you could actually look at the job while you could look at the service logs as well for Cloud Run while this is actually running in another window. But this should be close to being done here. And I guess I could open up another window for Google Cloud. So, and even put this, I could put this into the README, say push build on GCP 2. How about that? We'll just put a little note there and we'll just say git status, git add readme, and I can push that later. And so if we go back to this environment, building the container, building this, we should be able to go to GCP console and look at the logs for Cloud Run. I think they show up here. Yeah, there we go. Here's the service. And we should see all the different things. And look, it looks like it's deployed. Yeah, there we go. There's a service. And if we go, we just, we click on it. We have, I believe, yep, we have a production app. Pretty awesome, in my opinion. all the stuff that we've been able to build this quickly, and you can see the exact same stuff is happening. It's working. So essentially, once you understand automation with Python and how to build in cloud build environments, and you also know how to work with containers, really you have a superpower, and you can work on any cloud platform because of the fact that containers make it